Hi there. So I want to talk about discussion in Module 9, rich questions. Great discussion so far. I want to just add on to a lot of people said. Many people talked about how students approach a rich question. I think it's important to think about how a teacher approaches a rich question as well. I think that a question is only as rich as we, as teachers, can facilitate the discussion. A good colleague of mine did a TED talk on, what was it, Ignite talk, on represent the number 8, the best and worst question I've ever asked. So as a teacher, depending on the content knowledge and the prep that you've done in order to facilitate student groups that are working on this question, you can ask, and this is an elementary question, of course, you can ask students to represent the number 8, and they might write the number 8, they might write, you can ask them to represent the number 8 in as many different ways as they can. And they can write the word 8, and they can write the number 8 sideways and upside down, and that's different representations of the number 8, right? Or students might represent it as 6 plus 2, 2 times 4, 10 minus 2, 2 groups of 4 like you see on 2 dice. So that is a much richer way to represent the number 8. So it depends on what we've prepared our students for and how we've prepared students to do rich questions, and also understanding the different things that we value in mathematics. So representations, things like that. So that's important to think of, is what you're going to do to facilitate a rich discussion around a question. A lot of people talked about students passing on tough questions and just choosing not to do them and kind of skip over them. And that led to discussions on the discussion board about rewarding risk-taking and learning from mistakes. I think that rich tasks are a great way, and open questions and parallel tasks are great ways to foster that valuing mistakes piece. We come back full circle to growth mindset and how it's important for us to value mistakes and value learning, but if we're only asking questions where we're looking for a specific answer, that's not really valuing growth. That's wanting students to perform to that answer. Whereas if we ask rich questions where there's a low floor, high ceiling, there's a lot of muddling about in the question, that shows students that we're valuing learning, and also that we're valuing learning from mistakes and working on things that we don't know yet. I always say to my students that if you never get anything wrong in this class, then really there's been no point. You could have just stayed home and we could have called it a day, right? Because you've only shown me what you already know. The point of school is to come and work on things that you don't know how to do and that you will struggle with, and that's why school's difficult at times, and that's okay. So that was all really good, rich discussion. Finally, I wanted to just give you one example of a simple, rich question. They don't have to be big, complex questions. A good example, I think, of a rich question is my Tim Hortons task that I posted a while back. I shared it with you. If you look back through the module videos, you'll be able to find it if you haven't seen it yet. But another really good discussion that I've had in my class came from this question. I have a triangle. It's a right angle triangle, and it has a really, really little sign value, like close to 0. Tell me everything you can about this triangle. Okay? So if I ask that question, I want students to understand that a sine ratio is relating the opposite to the hypotenuse. And if it's close to 0, it means that the opposite is really, really little and the hypotenuse is quite a bit longer. So now you can start to visualize the triangle that I want my students to visualize, right? And so that's a triangle with a really, really little sine value, right? Sorry, that's an angle in a triangle that has a really, really little sine value, okay? So I want my students to be able to tell me that the opposite is a lot smaller than the hypotenuse, and that's fine if that's where they stop. That's, I think, a good understanding. But then I would also like them to start telling me about what does the other side look like. Is it closer in length to the opposite, or is it closer in length to the hypotenuse? Also, I might want them to think about what might this triangle represent in real life, right? Like maybe this triangle represents me standing really, really far away from a tree and looking at the top. And that's the triangle that I might make, right? So similarly, I might ask for a really, really little cosine value, right? So that might mean that I'm standing really close to a tower and I'm looking all the way up. Or I might ask for a sine value that's really, really close to 1, right? So all these different questions I can ask. I can also ask, I also want students to be able to discuss if something has a really, really little sine value, like close to 0, what does it mean for the cos value? What does it mean for the tan value, right? I want all those relationships to be built in my students' minds. That type of thinking we can't get from just rote questions. It's really important to have questions where students can enter and have rich discussions that kind of expands their understanding of mathematics and visualization. Okay, thank you very much, and have a great weekend. Go Raps, go!